Okay. So back in 2014, everyone had this dream, right? You upload a PDF for a document, maybe your company's handbook, maybe a research paper, and just talk to it. Ask some questions, get answers, simple. Except it wasn't simple. For almost a decade, this was a complete nightmare to build. And here is the thing nobody tells you. The hard part was never the AI model. The hard part was the plumbing. Everyone today talks about ChatGPT, Claude, these amazing models. But nobody talks about the six component assembly line that actually make these things works in production. The document loader, the vector database, the orchestration layer, that is the stuff that separates people who use AI from the people who build with it. This is the infrastructure layer, the hidden engineering that makes AI feel magical. So, if you want to actually understand how modern AI application works, and not just the surface level, but the architecture underneath, this is it. Let's break it down.
All right, look at this timeline. Three phases. 2014 to 2016, basically nothing worked. We had ideas, but the technology wasn't there yet. 2017, Google publishes Attention is All You Need. This is the transformer paper. This gave us BERT, GPT, all the models we use today. First time, we had a brain that could actually understand language, context, intent, nuance, not just keyword matching. But here's the thing, having a smart model is different from being able to use it with your own data. You've got this brilliant AI, but it only knows what it was trained on. It doesn't know your company's documents, your private information. So now we are in the engineering phase. The brain exists. The challenge is integration. How do you connect it to private data? How do you make it work with real workflows? That's what orchestration is about. Let me show you the problem we are solving. You have a 1,000 page internal document. Could be anything: engineering handbook, legal contracts, research papers. You ask, what are the assumptions of linear regression on page 372? Naive approach. Dump the entire document into the model. Three problems. Cost. These AP is charged per token. You're paying to process 1,000 pages when you only need one. Speed. Processing huge contexts is slow. Your users are waiting. Accuracy. When you give too much information, the model gets noisy. It's like handing someone an entire textbook versus the exact page they need. Which gets you a better answer? So the core problem, how do you give the AI just the relevant information? How do you filter 1,000 pages down to the 2 to 3 pages that actually answer the question? That's what this pipeline does. All right, here's why this feels different from traditional search. Control plus F looks for exact character matches. You search assumption, it finds every instance of that exact word. But if the document says prerequisites or conditions instead, missed completely. Semantic search understands meaning. You ask about assumptions of linear regression, it knows you want the concept, not just the word. How? Embeddings. The system converts your question and every chunk of the document into mathematical coordinates. Things that mean similar things end up close together in this space. So instead of searching for exact words, you're searching for meaning. The system calculates which document chunks are mathematically closest to what you're asking about. Result? Look at the bottom. It narrows 1,000 pages down to pages 372 and 461. Just the relevant ones. That's what gets sent to the LLM. Okay, let's break down the actual pipeline. Raw source, your data. PDF, Excel, cloud storage, whatever. Document loader, reads your files, extracts the text, gets it into a clean format. Text splitter, breaks the document into chunks, usually by paragraph or section. Can't process everything at once, so you chunk it. Chunks, discrete segments ready for the next step. The chunking strategy matters because this determines what gets retrieved later. Good chunking means precise retrieval. Bad chunking means you get irrelevant results. Bottom line, just like you eat one bite at a time, the system processes data in segments. This is the key piece, embeddings. Text is just words. Computers need numbers. So how do you convert linear regression into something mathematical? Step 1. Chunk goes to an embedding model, specialized model, not the LLM. Step 2. Output is a vector, list of numbers like 0.12 minus 0.45, 0.88. Could be 768 dimensions, 1536 dimensions. Step 3. Things that mean similar things have vectors that are close together. Look at this visualization. Virat Kohli, Jasprit Bumrah, Rohit Sharma, all cricketers clustered together. Pizza is way over there because it's unrelated. Distance in this space equals similarity. That's how you mathematically represent meaning. Once you have coordinates, you can measure distance. You can find what's related. That's the foundation. So now you've got vectors for all your document chunks. Where do you store them? Regular databases aren't built for this. You need vector databases. Function. Specialized storage designed to perform similarity queries. When you ask a question, it converts your question to a vector, then finds the closest matches in the database. The workflow. The 1000 vectors from your PDF get indexed here. Key insight. This scales memory beyond the LLM's context window. LLMs have token limits. Claude handles 200,000 tokens. GPT-4 handles 128,000. But you might have millions of pages. Vector database gives the LLM access to all of that without overwhelming it. It's persistent memory, long-term storage, critical for production systems. Let's put it all together. This is how the system actually responds to a question. Step 1. User asks, what are the assumptions of linear regression? Step 2. System converts the question to a vector. Step 3. Searches the vector database for similar vectors. Step 4. Regression top 5 relevant chunks based on similarity. Step 5. Takes those 5 chunks plus the original question, sends both to the LLM. The LLM generates a response. Result. Context-aware responses with high accuracy and low cost. You're only processing what matters, not wasting tokens, not overwhelming the model, just giving it exactly what it needs. Okay, so how do you actually build this? Look at this diagram. This is what it looks like when you code from scratch. A WSS3 over here, OpenAI API there, Pinecone database, Python scripts everywhere, spaghetti code. The problems: sequential tasks. Output of A must match input of B. Tons of manual glue code. Boilerplate. massive amounts of code just to connect things. Fragility. One API changes, everything breaks. This is why it was hard to build for years. You spent all your time on plumbing, not on features. Then orchestration frameworks emerged, changed everything. This is LangChain, open source framework designed to orchestrate the LLM ecosystem. Look at the diagram. Same components, AWS, OpenAI, Pinecone, embedding models. But now, LangChain sits in the middle as the orchestration layer. Value, plug and play functionality, pre-built components instead of writing everything from scratch. Role, infrastructure layer, managing the interaction between APIs, databases, and state. You focus on what you want your AI to do. LangChain handles the connections. This is what democratized LLM development. Solo developers can now build what used to require entire teams. Core concept, chains. Look at this. Load, to split, to embed, to store. Each link is one operation. Concept, chains are sequential operations. Data flows step by step. Functionality, output of one automatically becomes input for the next. No manual formatting. Benefit, streamlines execution. Document loader to text splitter to embedding model to vector store. In LangChain, that's just a chain. 4 lines of code. Define the sequence once. Framework handles the rest. This feature is critical for production. The problem? If you hard code for OpenAI, you're locked in. Want to switch providers? Rewrite your code. Solution. LangChain separates business logic from providers. Your core logic stays the same. Above it, you've got OpenAI, Google, Anthropic. Unified interface. Impact. Switch providers with one line of code. Change the model parameter. Done. This extends to everything. Embedding models, vector databases, cloud providers. Why it matters? AI landscape moves fast. New models every month. Prices change. You need flexibility. Memory and state. Here's the issue. User asks, explain linear regression. Bot explains. User follows up. Give me interview questions about it. What's it? Linear regression, obviously. But LLMs are stateless. Each call is independent. The model doesn't remember the previous question. Solution, conversation memory. Tracks history, injects past context into current query. When you say it, the framework knows. It equals linear regression from earlier. This enables multi-turn conversations that feel natural. Without memory, every question is isolated. Now we are getting into what's next. The shift from assistants to agents. Knowledge assistant, read-only. Answers questions using data. Agent, action-oriented, has access to tools, executes tasks. Agents are chatbots on steroids. Knowledge assistant example. What's the cheapest flight to New York? It searches and tells you. Agent example. Same question, but it books the ticket for you autonomously via API. This is the transition happening now. AI moving from informational to operational, managing calendars, processing invoices, handling customer tickets. Let's zoom out. Full stack. Bottom, foundational models. OpenAI, Hugging Face, Gemini, the brains. Middle, orchestration layer, LangChain, the infrastructure connecting everything. Top, applications, agents, chatbots, tools, what users interact with. Ecosystem, LangChain integrates with 50 plus text splitters and every major data source. Alternatives, Llama Index for data heavy apps, Haystack for retrieval pipelines. Key point, orchestration frameworks are the infrastructure layer scaling AI applications. The brain exists. Now it's about how you integrate it into real systems. All right, that's the architecture. From the 2014 dream to the engineering reality today. Orchestration frameworks solve the plumbing problem. Now you can actually build. If this was helpful, subscribe. I've got more coming on AI architecture, RAG systems, agent frameworks. Thanks for watching. See you in the next one.